Hello there, here we go again in the fifth episode in our Rust programming course. Today we will talk about variables in more detail. We will know about the data types in Rust and difference between immutable variables and constants and many other things. So let's get started. Okay, instead of recording the whole screen, I will record the terminal region only. Maybe this is gonna make the video less in size or something. Maybe. Okay, I'll start. Every piece of data in Rust is of a certain type, which tells Rust how to deal with that data and what operations that could be applied to it and what could not. Rust has two types of data, scalar types and compound types. In this episode, we will discuss the scalar types only, and we will complete our discussion about variables in the next episode, which is gonna be about the compound types and other things like variable sharing and many things. Okay, first of all, scalar in Rust means a single value. So a scalar type or a scalar variable is a variable that could save only one value at a time, unlike arrays or tuples, which can hold a large amount of values with a specific index for each value. There are four primary scalar types in Rust: integers, floating point numbers. It's the variable that can save decimal numbers. Maybe you know about it. Booleans and characters. You will likely recognize these types from another programming language like C or C++ or C# or Java or any language. But let's know how they work in Rust. The integer type. In almost every programming language, the integer type has two flavors, signed and unsigned. But before talking about the difference between the signed and the unsigned integers, we will talk about the types of the integer variables in terms of the length. Rust has 5 types of integers with different sizes: 8, 16, 32, 64, and isize, or the architecture size. Maybe all of them are familiar to you except the last one, but don't worry, I will tell you about it, but not at this moment. Now we know that there are two types of integers, signed and unsigned, and each of them has 5 different sizes. But what is the real difference between the signed and the unsigned integers? Okay, using the unsigned integer, or using the signed integer, you are telling the compiler that this number could be a negative number, so reserve a bit to represent the sign because it makes sense. But the unsigned integers or the unsigned numbers are positive by default. It's like writing a number on a paper. If the sign is important, you will write it beside the number. If not, you will write only the number and the reader will consider it to be a positive number by default. And because the unsigned integer saves only positive values, it can save more numbers in the positive direction more than the signed integer. I won't go on the range of each size, but put it in your head. The greater the size, the greater the range. And if you want to know the exact range for each size, I will leave you a mathematical formula that you can apply to get the exact range of each size. What else? Oh yeah, that's for the numeric or the popular size, but what about the isize type? Isize depends on the machine. Depends on the machine that the program runs on. If you are on a 32 bits machine, then isize will be i32. And if you are on 64, isize will represent i64 or 64 bits integer. Now let's move to the floating numbers. there isn't too much to say about the floating numbers. What goes on the integers almost goes on floats, but it's notable to say that the default floating number size in Rust is 64 bits because the 32 bits machine can deal with a 64 bits floating variable, but it will be a little bit slower, but it's not an error prone, and slower operation with better precision is very reasonable if the precision is important for your program. It's notable too that if you try to add a decimal number to an integer, Rust will round up or round down the decimal part and treat it like an integer, the Boolean type. Usually, it's been used with if statement. We will discuss if statement when we talk about the control flow and taking decision, but for now, all I want you to know is that the bool variable has only two cases, true or false. And last but not least, the character variable. It's a variable that can only store a single character. You can define one using char keyword. We will see it when we begin to write code, which is now. I will move to the desktop and create a new project using cargo new vars ben, and I will cd to the folder and I will launch them. Okay. And main. I will define a variable of each type and I will assign it a value and denote its type with a comment beside it. Let a of type unsigned integer 32 bits u 32 equal 10. Unsigned integers let be I32 20. Because it's signed, I will use one of its feature to assign a sign. I will make it negative 20. Signed integer. I forgot the semicolon, but it's not a big deal. Floating variables. Let's see. I will leave this for the type inference 5.2. This will represent a 64-bit floating variable because we said the default is 64. And this is the 32 bits float. Characters, okay, let d char d. Know that I used a single quotation mark, not a double quotation mark. Always use a single quotation mark with characters, and the double quotation mark used with strings only. What else? Yeah, bools. Let e bool equal false. Well, why not? Now let's print out these values. Print ln 1, 2, 3, 4, 1, 2, 3, 4, 5, yeah, 6, 1, 2, 3, 4, 5, 6, A, B, C, D, there's two D's. I will change it to B, E, and that's gonna be F. Now let's compile this project. I will go now. I need only a new tab. Cargo run. Sure enough, it gives us our values. But what if I change this 10 to be a negative 10? Can you see? Compile error. You can't assign a negative value to an unsigned integer or an unsigned variable. I think that's all for this episode, but no, there is one more important thing to say. We said that the difference between the mutable and the immutable variables is that the immutable variables could have its value changed at any part of the program, when you can't change the value of a mutable variable. So what's the difference between it and the constants? The difference really shines when you wanna have, or when you have a value that won't be changed, but you don't know what its value gonna be. Like you are loading data from configuration file and you want this data to be protected and you don't want it to be changed. In this case, the usage of immutable variable says, hi, use me. But what about the constants? Okay, the constant needs a fixed value and type when you define it. Constants do not support the type inference. You can use constants in many other cases, like you are creating a game and you want to set the maximum number of points that a player can earn, or something like that. Or you're creating a program that do math and you want to define some math constants like pi and stuff. Maybe pi and other math constants are predefined constants in the math standard library, but we're just saying. What else? Let's define some constants. I will remove this code. Now let's create our main function. F and main. And define a constant. Constants are defined using const keyword, not let like the variables. Const, the constant name, which is x for instance, and the constant type, because as we mentioned, constants do not support the type inference feature. Let's make it a character equal d. Now let's compile this and run it. I want to show you something. Cargo run. Sure enough, it compiled successfully, but with the warning, because the traditional naming convention in Rust for the constants is to be all characters in uppercase. So if we change this x to be capital X and we compile it, that still gives us a warning, but because x is never used, not because the case of the letter. What else? What if we tried to change the value of a constant? Let's assign x another variable, x equals c. error, because it's a constant, you can't change its value. That's it for this episode. Subscribe for my channel for my videos and turn the notifications on, and share this video and like it and do that stuff you know about it, and see you soon.